Hello, this is a video about the Pythagorean Theorem and simple trigonometry. So here we have a right-angled triangle. A right angle is 90 degrees. In a right angle, we can use the basic trigonometric ratios of Sohcahtoa. Sohcahtoa. These refer to this angle here. And what this means is that if we want to calculate the sine of this angle, this is the same as, so sine theta is equal to the opposite over hypotenuse. So the opposite of this angle here would be B, and the hypotenuse is always the longest side of a right angled triangle. So in this case, sine theta will equal to opposite, which is B over C. So B over C. Similarly, what about cosine theta? So cos theta, here AH refers to adjacent over hypotenuse. So cos theta would be adjacent, which is A, divided by the hypotenuse, which is C. So it would be A divided by C. And finally, tan theta. So tangent theta is equal to opposite divided by the adjacent. So in this case, it would be B divided by A. And in a right-angled triangle, they always follow a rule called the Pythagorean Theorem, which means in a right-angled triangle, the sum of the squares of the two non-hypotenuse sides is equal to the square of the hypotenuse. In this case, what that means, it is a squared plus b squared equals c squared. So the square of the hypotenuse is equal to the sum of the squares of the other two sides. So we'll jump in by looking at a past paper question. So here they say JGR is a right-angled triangle. JR equals to 50 meters and JG equals to 20 meters. And we have to calculate angle JRG. So angle JRG would refer to this angle. We'll call it X. And then based on what's given here, we have to think of the trigonometric identities that has been given to us. So here, according to this angle, we have the opposite, which is 20 meters, and we have the hypotenuse, which is 50 meters. Now, which of the trigonometric identities used these opposite and hypotenuse? Well, if you think about Sohcahtoa, we know that it's sine, because sine was so. So, based on this, we can conclude that sine x equals to opposite divided by hypotenuse, which is the same as 20 meters divided by 50 meters, which equals to 2 over 5. Now, to find x based on a fraction, you have to use an inverse sine feature on your calculator. So that can be achieved by pressing the second button and the sine button. That gives you sine -1, you see? So this expression is same as x equal to inverse sine of 2 over 5. So let's enter it here right away. Inverse sine of 2 over 5. That gives us a wide range of numbers. Now, in every question, unless otherwise stated, it's always best to give your answers to 3 significant figures. So if we give this answer to 3 significant figures, that would equal 23.6 degrees. Next, we'll look at this question. This is also a very typical GCSE question. Let's read the question together first. Two circles, centers O and C, of radius 6 cm and 4 cm respectively, touch at Q. PT is a tangent to both circles. Write down the distance OC. So, at first glance, it may seem like, oh, how do I do this question? They don't have enough information. But upon closer inspection, you can actually see that the distance OQ is the same as distance OP, because they are both the radius of the bigger circle. Similarly, the distance from C to T is the same as the distance from C to Q. So based on that, we know that this is 6 cm and this is 4 cm. So that would be 6 plus 4 equals 10 centimeters. Now let's look at question B. Calculate the distance PT. To do this question, you have to use this information here given. PT is a tangent to both circles, which means that these angles here are right angles. Now, what we can do is we can push the line upwards here, if you visualize it, so that we have a new right angled triangle here. And we already know the length of the hypotenuse from question part A, right? So this is 10. And we know that the distance here from O to this part here would be 2, because that's the difference between 6 and 4. Now we can use the Pythagorean identity as this is a right angled triangle. By the Pythagorean identity, let's say this length here is y. This tells us that 2 squared plus y squared equals 10 squared. We can rewrite this as 4 plus y squared equals 100, which then goes to y squared equals 96. Now, let's use a calculator to evaluate the value of y. To do that, go to your calculator, press the square root button, and then divide 96. That gives us 4 root 6. So the answer, y equals 4 root 6. So PT equals 4 root 6 cm. Now, for those of you, let's say if this was a paper 2, so you can't use a calculator and you have to find the square root of 96 manually. An easy way to do it is think about how you can divide the numbers here. So I'll show you how to evaluate the square root of 96 manually without using a calculator. So let's do that here. To evaluate the square root of a number without using the calculator, you have to divide the numbers into smaller parts. The easiest way to do it is just divide by 2 as much as you can. So this is the same as root 2 times root 48. We agree? Then this can be rewritten further to root 2 times root 2 times root 24. And then we can divide this again into, so root 2 times root 2 times root 2 times 12. Let's do it one more time. Root 2 times root 2 times root 2 times root 2 times root 6. Now, we know it's really hard to divide 6 anymore, but because even if you had a root 2, it wouldn't match up with the other root 2. So what we'll do here is when you multiply two thirds of the same number, this is 2 times, here again it's saying 2 times root 6, right? That gives us 4 root 6. Well, now this time we'll look at a 3D question. So previous questions were 2D, but in the GCSE questions, they usually like to give you 3D questions as well. So let's try this question. The diagram shows a pyramid with a square base A, B, C, D. All the sloping edges of the pyramid are 20 centimeters long, with AC being 17 centimeters. Calculate the height of the pyramid. So by the height of the pyramid, it would be referring the distance from the top of the pyramid up to the base. So this distance here, essentially. To do that, we have to firstly look for a right-angled triangle. The distance from V to the base is at a 90 degrees angle to the baseline. What this means is that the line here would actually form a right-angled triangle like that. Do you see? It's 3D representation, so it might be hard to see at first glance. But if you think about it, it's basically a right-angled triangle that's in the shape of this. And we're trying to find the distance here, which is the height. And how do you find the other two distances? Well, for this distance here, it's given as 20 centimeters. And for this distance, this is just half of 17 centimeters here. So 17 divided by 2 is 8.5. So this would be 8.5. Now, let's use the Pythagorean identity to solve this question. The Pythagorean identity tells us that x squared plus 8.5 squared equals 20 squared. By using the calculator, we can rewrite this equation as x squared equals 327.75. Now let's use the calculator to find the square root of this number so we can find x. So to do that, square root 0.75 gives you, again, 3 significant figures unless stated. So that gives us x equals 18.1 centimeters. And this is the final question we'll be attempting for today. This is a bit more of a tricky type of question because it's 3D and it requires quite a lot of complex thinking processes involved. But let's jump right away. The diagram shows a prism of length 4 cm. The cross-section is a right-angled triangle. BC equals 3 cm and CQ equals 2 cm. They want us to calculate the angle between the line AQ and the base ABCD of the prism. So what they want us to find is the angle between this line here and the base. So that would be the line like that, if you think about it. You see? But in order to find this angle, we firstly have to find the distance from A to C. So try to make a 3D visualization. This would also be a right angled triangle here, with this being a side, AC being a side, and AQ being the hypotenuse. And we want to find the angle here, right? In order to find the length of AC, we have to first use another Pythagorean theorem and the triangle ABC, because this is a rectangular base. We know that this here is 90 degrees actually. By using that, to find the first length AC, so we know that AC squared is the hypotenuse of the triangle ABC, equals 4 squared plus 3 squared, which equals to 25. So that gives us AC equals to 5 centimeters. So we know that the length here is 5 centimeters. Now we're ready to find the angle here. So let's say we'll label this angle as theta. Okay, so angle theta, we have the adjacent and the opposite. Using the basic trigonometric ratios, Sohcahtoa, we know that we can use tangent to find the value of this angle. What this tells us is that tangent theta equals to opposite over adjacent, which is 2 over 5. We can rewrite this as inverse tangent of 2 over 5 equals to theta. Now let's use a calculator. Inverse tangent 2 over 5. Again, unless stated, very significant figures. So we know that theta is approximately 21.8 degrees.